Greetings from K.S.Rangasamy College of Technology. This is Dr. S. Muthukumar, Assistant Professor from Department of Mathematics. In this video, I am going to explain about the homogeneous linear partial differential equations. Greetings from K.S.Rangasamy College of Technology. This is Dr. S. Muthukumar, Assistant Professor, Department of Mathematics. In this video, I am going to explain about the solution of homogeneous linear partial differential equation. Let us consider the general form of nth order homogeneous linear partial differential equation with constant coefficient. That means a naught into dou power n is divided by dou x power n plus a1 into dou power n is divided by dou x power n minus 1 into dou y plus etc. an into dou power n is divided by dou power y power n equal to function of x and y. The following operators can be used to denote the derivative dou by dou x and dou by dou y to simplify the above equation. That means d equal to dou by dou x and d dash equal to dou by dou y. Use these operators in equation number 1. So the simplification of the equation 1 is a naught into d power n plus a1 into d power n minus 1 into d dash plus etc. an into d dash power n equal to function of x comma y, where f of d comma d dash is the homogeneous polynomial of the nth degree in d and d dash. The complete solution of the above equation is given as z equal to complementary function plus particular integral, where the complementary function is the solution of the equation f of d comma d dash of z equal to 0, and the particular integral is given by 1 by f of d comma d dash into f of x comma y. Now see the procedure for evaluating the complementary function. Complementary function of the solution of the linear PDE is the solution of this equation. This a naught d power n plus a1 d power n minus 1 into d dash plus etc. plus an d dash power n into z equal to 0. In this equation, replace the value of d by m and d dash by 1 to get the auxiliary equation. So the required auxiliary equation is a naught into m power n plus a1 into m power n minus 1 plus etc. an, which is a nth degree equation. So it has n different roots, n roots. The roots may be equal or different. Let us assume that the n roots are m1, m2, etc. mn. Based on the nature of these roots, we can write the different form of complementary function for the given PDE. If the roots of the auxiliary equation are distinct, it may be real or complex, then the general solution, that means complementary function, can be written as pi 1 of y plus m1x plus pi 2 of y plus m2x plus etc. pi n of y plus mnx. If any of the two roots are equal means, that means the first two roots are equal means the complementary function can be written as in this form: pi 1 of y plus m1x plus x into pi 2 of y plus m1x plus etc. in plus pi n of y plus mnx. Now see the procedure for calculating the particular integral value. So pi is 1 divided by f of d comma d dash into right side function. So in this case, I am assuming the right side function of x comma y as a exponential function in terms of e power ax plus b. Then pi equal to 1 divided by f of d into e power ax plus by. In this case, substitute the values for d and d dash. Here d equal to, d can be replaced by the coefficient of x, and d dash can be replaced by the coefficient of y when f of x comma y is an exponential function. Then pi equal to 1 by f of a comma b e power ax plus by. It is applicable only when f of the denominator value not equal to 0. If the denominator is equal to 0 means, that means f of a comma b equal to 0 means pi can be evaluated in this manner. That is, multiply the numerator by x and differentiate the denominator with respect to d and then follow the same procedure. So the main aim of the particular integral calculation is to eliminate the d and d dash value from the given function. This is the rule 2. It is applicable for trigonometrical function sin of ax plus b or cos of ax plus b. In this case, the right side function is in the form of trigonometrical. That means sin of ax plus b or cos of ax plus b. In this case, replace the values for d square, d dash square and d dash. Here d square equal to minus of x coefficient square. That means minus of a square. D dash square is replaced by minus of y coefficient square. That means minus b square. Whereas d and d dash is replaced by minus of multiplication of x and y coefficient minus of ab. It is applicable only when f of minus a square comma minus ab minus b square not equal to 0. If the denominator is equal to 0 means modify the procedure. That means multiply the numerator by x and differentiate the denominator with respect to d and then eliminate the d and d values as discussed in the first step. Now this is rule 3. In this case, the right side function is an algebraic expression. That means x power m into y power n. Here pi equal to 1 divided by f of d comma d dash into x power m into y power n. Now change the fractional term into the form of binomial expression. That is 1 plus or minus whole power minus 1 form, and then apply the binomial theorem. Finally, use the operator d and d dash to eliminate the terms, which gives the final particular integral value. Now come to the problems. So here the problem is solve d square minus 2d d dash plus d dash square into z equal to 0. So the complete solution of this problem is the complementary function plus particular integral. Here there is no right side function, that is right side value is 0 here. So there is no need to find out it is not possible to find out the particular integral value. So the complete solution contains the complementary function only. So first to form the auxiliary equation. Here the given equation is d square minus 2d d dash plus d dash square into z equal to 0. Now replace d by m and d dash by 1. So the auxiliary equation is m square minus 2m plus 1 equal to 0. The root of this equation is 1 comma 1. It is real and equal values. So the complete solution, that means complementary function is f1 of y plus x into, because of the roots are equal, x into f2 of y plus x. If the roots are equal means we have to multiply x by the in front of the function. This is problem number 2. Solve dq plus d square into d dash plus d dash square plus d dash square cube into z equal to 0. It is a third order problem. So its corresponding auxiliary equation is m cube plus m square plus m plus 1 equal to 0. Now take the m square as a common one from the first two terms. So m square into m plus 1. The remaining two terms can be written as m plus 1 equal to 0. Now choose the m plus 1 as a common one. So the resultant form is m plus 1 into m square plus 1 equal to 0. Now either m plus 1 equal to 0 or m square plus 1 equal to 0. It gives m equal to minus 1 and m equal to plus or minus I. So the roots are 1, minus 1 comma I comma minus I. So all the roots are different one. So its complementary function is z equal to f1 of y minus x plus f2 of y plus ix plus f3 of y minus ix. Now see the problem number 3. Find the general solution of 4 into dou square z divided by dou y square minus 12 into dou square z by dou x dou y plus 9 into dou square z by dou y square equal to 0. So the problem is given in the standard form. So use the notation for the derivatives. Dou square z by dou x square, dou square z by dou x dou y, dou square z by dou y square. That means replace dou by dou x by z, dou by dou y by d dash. The simplified form is 4d square minus 12d d dash plus 9d dash square into z equal to 0. It's the auxiliary equation 4m square minus 12m plus 9 equal to 0. Okay, use the quadratic formula to find the root values. That means m equal to minus b plus or minus b square minus 4ac divided by 2a. Here a equal to 2, b equal to minus 12, c equal to 9. So using these values in the quadratic formula, we can get the value of m. Here the m values are equal to 3 by 2. So here the values are equal. So this general solution is that equal to f1 of y plus 3 by 2x plus x into f2 of y plus 3 by 2x. So this is type 1 problem. In this case, the right side function will be an exponential function. It is in the form of e power ax plus by. See the problem. Solve d cube minus 3d d dash square plus 2d dash cube into z equal to e power 2x minus y. First write the given equation. The solution of equation 1 is complementary function plus particular integral, because of there is some right side function, there is some right side value. Now write the auxiliary equation for the given equation. It means replace d by m and d dash by 1. So d cube equivalent to m cube minus 3d d dash square equivalent to minus 3m plus 2 d dash cube equivalent to plus 2 equal to 0. So which is a third degree equation. So use synthetic rule to find out the roots. That means first identify one of the initial root of this equation by giving different values for m. Here m equal to 1 satisfies the given equation. So m equal to 1 is the one of the root. Then apply the synthetic division rule here. This is m cube coefficient, this is m square, there is no m square term. So write it as 0, then m coefficient minus 3, then constant 2. So use the first root to reduce this degree. So it is reduced to m square plus m minus 2 equal to 0. So its factorization m plus 2 into m minus 1 equal to 0. So the roots are 1 comma minus 1 comma minus 2. So this 1 comma 1 comma minus 2. The roots are 1 comma 1 comma minus 2. Two root values are equal and one is different from the others. So use x into form. So the complementary function is x into f1 of y plus x plus f2 into y plus x for the different value f3 of y minus 2x. Now come to the particular integral calculation. So pi equal to 1 by f of d into right side value e power 2x plus y. So it is an exponential function e power 2x minus y. So in this case we can replace the value for d and d dash. Now substitute d equal to 2, which is the coefficient of x, and d dash equal to minus 1, which is the coefficient of y. So the above pi value equivalent to 1 divided by 2 cube minus 3 into 2 into minus 1 whole square plus 2 into minus 1 whole cube. So it's reduced to form 1 divided by 8 minus 6 minus 2 into e power 2x minus y. That is 1 by 0. Here the denominator value equal to 0. So it gives pi value as infinity. So it is meaningless because of vi has some value. So in this case, we have to modify our procedure to find the particular integral. So for that, multiply the numerator by x in this step and then differentiate the denominator with respect to d. This x divided by dou d of d cube minus 3d d dash square plus 2d dash cube into e power 2x minus 5. Now differentiate the d terms only. So the d cube, this is the first d term. So d cube equivalent to 3 into d square. This is the second d term minus 3 into d differentiation 1 into d dash square into the function exponential function. Again d and d dash terms repeats. So this is an exponential function, so we can repeat the same procedure. That means substitute d equal to x coefficient and d dash equal to y coefficient. So here replace d by 2 and d dash by minus 1, which gives the value as x by 9 into e power 2x minus 5. So all the terms in the particular integral are cancelled. All the d terms are cancelled in the particular integral equation. So which is the final particular integral value. Now comprise the final solution, that is complete solution, by adding complementary function and the particular integral. Now the complete solution is z equal to x into f1 of y plus x plus f2 of y plus x plus f3 of y minus 2x plus x by 9 into e power 2x minus y. So this is the second problem. Find the complete solution of the following homogeneous linear PDE d square minus 2d d dash plus d dash square into z equal to 8 into e power x plus 2y. Here also the exponential function is given. The complete solution for the given equation is z equal to complementary function plus particular integral. First to find out the complementary function. For that we need the auxiliary equation for the given one. So write the auxiliary equation by substituting d and d dash values. By substituting the values for d and d dash. So here d square equal to m square minus 2d d dash equal to minus 2m plus d dash square equal to 1. So m square minus 2m plus 1 equal to 0. So its factorization gives the root of this auxiliary equation. Here the roots are 1, 1. That is real and equal values. So its complementary function is f1 of y plus x plus x into f2 of y plus x. Now move to the particular integral calculation. So particular integral equal to 1 divided by f of d into 8 into e power x plus 2y. So this is in the form of exponential function. This type 1 case. So in this case substitute d equal to x coefficient, that is d equal to 1 and d dash equal to y coefficient. Here y coefficient equal to 2. So d dash equal to 2. So which gives the answer 1 square minus 2 into 1 into 2 plus 2 square. Here the answer is 1 by 1 into 8 e power x minus 1. That means 8 into e power x minus x plus 2y. So the general solution for the given PDE is z equal to f1 of y plus x plus x into f2 of y plus x plus 8 into e power x plus 2y. So this is the next problem. Now see the problem. D square plus 4d d dash minus 5d dash square into z equal to x into y plus sine of 2x plus 3y. So the right side functions are the combinations of algebraic and trigonometrical functions. There are two functions on the right side. As usual, follow the rule for calculating the complementary function. Here the roots are 1 comma minus 5. So its complementary function pi 1 of. We can use the different notations for the function. We can use either f or pi or g. Here pi 1 is followed. Pi 1 of y minus 5x plus pi 2 of y plus x. Now particular integral calculation, 1 divided by f of d into the right side function xy plus sine of x plus 2y. So there are two functions. So first separate it. The first one is 1 divided by d square plus 4d d dash minus 5d dash square into xy. The second one is 1 divided by d square plus 4d d dash minus 5d dash square into sine of x plus 2y. So the first particular integral comes under the type 3 category and the second one comes under the type 2 category. Now see the cancellation of d and d dash for the function x into y for the algebraic function. So in this case, take the first term, that means d square term, as a common one from the denominator. So if the functions are in the form of algebraic, means we have to take the, that is, we have to convert the denominator into the form of binomial expression. For that, take d square as a common one from the denominator. So d square into 1 plus d dash. So the remaining terms can be written as in this form, d dash divided by d square into 4d minus 5d dash into xy. It can be written as 1 plus d dash divided by d square into 4d minus 5d dash whole power minus 1. Now this expression is in the form of 1 plus x whole power minus 1. Here x is assumed to, x is equivalent to this term, d dash divided by d square into 4d minus 5d dash. Now expand this series. There is 1 plus x whole power expansion, 1 minus x plus x square, etc. Here x is equivalent to d dash divided by d square into 4d minus 5d dash. So this is the first term 1, then minus x plus x square, etc. So there are infinity terms in this series, but it has some values. The remaining values are 0. So that values are fully based on the powers of this y term. Here the power of y is 1. So the higher derivative of d, it means derivative of y, that means the derivative of y with respect to y. Okay. Okay, this is the type 3 form. Here 1 by d square plus 4d d dash minus 5d dash square into xy. It is an algebraic expression. So to cancel this d and d dash, we have to convert this denominator as into the form of binomial expression. For that, take the first term as a common one. So here I am taking d square as a common one from the denominator. So d square into the remaining terms can be written as 1 plus d dash by d square into 4d minus 5d dash into xy, which is equivalent to 1 plus d dash by d dash square into 4d minus 5d dash whole power minus 1. It is in the form of 1 plus x whole power minus 1. Here the term d dash by d square into 4d minus 5d dash is assumed to be equivalent to x. Now expand this function by using binomial expression, 1 plus x whole power minus 1. That means 1 minus x plus x square minus x cube, etc. Here the first term is 1 and the x term is d dash by d square into 4d minus 5d dash plus etc. So there are infinity terms. Now the derivatives more than 1 values are 0 because of here the y power is 1. So here the value exists for the terms 1 and d dash only. Since y differentiation, second derivative of y is 0, so no need to consider the higher derivative of y. That means second or more higher order derivatives. Here I am considering the 1 and d dash term only. So which is equivalent to 1 by d square into xy minus 1 divided by d square into d power 4 into 4 d dash, this d dash into xy. Here d dash stands for the differentiation of the function with respect to y. 1 by d stands for the integration of the function. 1 by d square means 2 times of integration of the function. 1 divided by d power 4 means 4 times integration.